Hello students, welcome back to this lecture series of ICM. In previous video, I had explained about FSK, that is frequency shift keying. In this video, we will see about phase shift keying. So let's start the session. Before that, I am introducing about the today's course outline. Firstly, we see the solution for our previous video's question. Next, we will switch to phase shift keying, its waveforms, and then advantages and disadvantages of this. After that, we will see some important questions related to this topic. First of all, we will solving our previous session's question, that is, we need to send data 1 bit at a time at a bit rate of 3 Mbps. The carrier frequency is 10 MHz. Calculate the number of levels, calculate the baud rate and the bandwidth with FSK. Here you will have to use 2 delta f is equal to 1000 kHz and d is equal to 1. Given bit rate is equal to 3 Mbps, r is equal to 1 and carrier frequency is equal to 10 MHz. Therefore, level L is equal to 2 to the power r, which is equal to 2 to the power 1, since r is equal to 1 and 2 to the power 1 is equal to 2. Since r is equal to 1, therefore baud rate is equal to bit rate divided by r, that is equal to bit rate divided by 1, and that is equal to bit rate. So baud rate is equal to bit rate is equal to 3m baud. Now for bandwidth, we have equation, that is B is equal to 1 plus D multiplied by S plus 2 delta F, where 2 delta F is equal to 1000 kHz, which equal to 1 MHz. Therefore, bandwidth B is equal to 1 plus 1 multiplied by 3 plus 1, which equal to 7 MHz. Now, let's start our today's topic, that is PSK, that is phase shift keying. It is a digital modulation process which conveys data by changing or modulating the phase of a constant frequency reference signal, that is the carrier wave, or we can also define it as the phase of the analog carrier signal which changes with respect to amplitude of the digital information signal. We vary the phase shift of the carrier signal to represent digital data. For example, bit 0 can be represented by 0 degree phase and bit 1 can be represented by 180 degree phase. Here in this figure, you can see the PSK modulated waveform along with its input. As you can see here, for binary 0 in our input signal, then in the output modulated signal, we will see signal in 0 degree phase. And for binary 1 in input, then in output we get signal in 180 degree phase. This is a case of PSK where we have only 2 phases. So it is known as BPSK, that is binary phase shift keying. Now for bandwidth, let B be the bandwidth where B is equal to 1 plus D multiplied by S, and this equal to ASK's bandwidth, where D is equal to the factor related to modulation and filtering whose value lies between 0 and 1, and S is equal to symbol rate or baud rate of the signal. And PSK is much more robust than ASK, as it is not that vulnerable to noise which changes amplitude of the signal. Types of PSK. There are various types of PSK such as BPSK, that is binary phase shift keying, QPSK, that is quadrature phase shift keying, DPSK, that is differential phase shift keying, and OQPSK, that is offset quadrature phase shift keying. Now firstly we see about BPSK, that is binary phase shift keying, when we have only 2 different phases which are used for modulating then it is known as BPSK. For a zero binary input, the phase is of 180 degree, which is shown here in the diagram. This figure represents BPSK modulated waveform along with its input. As you can see here, for binary 0 in our input, then in the output modulated signal, we see signal in 0 degree phase, and for binary 1 in input, then in output we get signal in 180 degree phase. Next is QPSK, that is Quadrature Phase Shift Keying. Sometimes this is also known as Quadratic Phase PSK or 4PSK. Quadrature Phase Shift Keying or QPSK is a form of phase modulation technique in which two information bits which are combined as one symbol are modulated at once. Selecting one of the four possible carrier phases, shift changes. Instead of the conversion of digital bits into a series of digital stream, it converts them into bit pairs. This decreases the data bit rate to half, which allows space for the other users. Various phases for various bit combinations are represented in this waveform, like 00 is represented at 45 degree phase, 01 is represented by 135 degree phase, 10 is represented by 225 degree phase, and 11 is represented by 315 degree phase. DPSK, that is Differential Phase Shift Keying. In DPSK, the phase of the modulated signal is shifted relative to the previous signal element. No reference signal is considered here. The signal phase follows the high or low state of the previous element. In differential encoded BPSK, that is DBPSK, a binary 1 may be transmitted by adding 180 degree to the current phase and a binary 0 by adding 0 degree to the current phase. In DQPSK, the phase shifts are 0 degree, 90 degree, 180 degree, minus 90 degree or 270 degree, which are corresponding to the data 00, 01, 10 and 11. Next is OQPSK, that is Offset Quadrature Phase Shift Keying. It is a variant of phase shift keying modulation using 4 different values of the phase to transmit. It is sometimes called as Staggered Quadrature Phase Shift Keying, that is SQPSK. QPSK has a disadvantage of sometimes having a direct 180 degree shift, due to which amplitude will be changed. So this is the solution for this problem. Here direct 180 degree shift is not allowed, as we can see in the figure. Here you can see whenever there is a shift of direct 180 degree in QPSK, the phase will be changed by 90 degree in t by 2 time, so that at t time we get 180 degree shift in QPSK. Lastly, some important questions for you all. Explain what do you mean by PSK, its advantages and disadvantages. Explain what do you mean by QPSK and what do you mean by OQPSK. That's all for today's session. Thank you for watching the video. We will meet soon with our next topic.